Question 5. At the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation given for the next 20 years. W is measured in tons and T is measured in years from the start of 2010. Part A. Use the line tangent to the graph of W at t equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010 at time t equals 1/4. Okay, so it told me to use a tangent line to estimate. So the first thing that I need to do is actually to find a tangent line, which you remember is going to be y equals mx plus b. Okay, you'll notice in this problem I was not given an x and a y, I was given a w and a t. Just from looking at this part right up here, I know the w is going to be my y and my t is going to be my x. So just keep that in mind as we are doing this. So I might even put w equals t plus b. I think that will make more sense to me. All right, so first thing that I need to do is know the slope. And the slope is a derivative, and nicely they gave me the derivative. So what I'm able to do for this problem to get m, it's just the derivative. I have 1/25. The w, actually they gave that to me because they told me at time equals 0 there were 1,400 tons of solid waste, and that's what w has to do with, is how much waste. So I can put 1,400 minus 300, and that will give me 1,100 over 25, and that reduces to 44. All right, so that's m, and now I'm going to have w equals m, which was 44t plus b, and now I get to put in my t and my w. So again, at time equals 0, there were 1,400 tons of waste, so 1,400 equals 44 times 0 plus b, which means by b must be 1,400. So the equation of my line, my tangent line, is going to be w equals 44t plus 1,400. Now that wasn't the question. It said to use that line to approximate how much waste is in the landfill at time t equals 1/4. So now I'm going to plug in 1/4, and 44 times 1/4 is 11, plus 1,400 will be 1,411 tons of waste. All right, that was worth 2 points. If you found out the slope was 44, give yourself a point. And then if you found that there were 1,411 tons, give yourself a point. All right, part B. Find d squared w dt squared in terms of w, and then use that to determine whether your answer in part A is an underestimate or overestimate. Okay, so d squared w, that means to find the second derivative. Fortunately, we were already given the first derivative. We know that dw dt is equal to 1/25 w minus 300. And I'm just going to distribute that a second. So I'm going to get 1/25 w minus 25 times 300. Let's see. I believe that will be 12. Okay, and then from here, so that's still dw dt, to take the derivative of that, so to get d squared w dt squared, the derivative of 1/25 w is just going to be 1/25, but remember w is acting like the y in this case, so whenever we take the derivative of y, we always put dy dx, so for this one we need to put dw dt. And then the derivative of 12 is just a constant, so it's 0. Okay, so from here, we'd be fine, except it said to put it in terms of w. So I need to go one step farther, so I'm going to put 1/25 times, I do know that dw dt is equal to 1/25 w minus 300. So simplifying that just a little bit, that will give me 1/625 w minus 300. Okay, that was worth 1 point. Okay, and then my final point, it said to determine whether your answer is an underestimate or an overestimate. Okay, if I'm talking about the second derivative, I'm talking about concavity. So if I'm looking at the concavity, I know that I'm starting with 1,400, so if I have 1,400 and it's increasing, so 1,400 or anything above, the second derivative will always be positive. So I know that this will be a concave up function. And if the graph is concave up, so I've got an increasing concave up function, then when I do a tangent line at any spot, so if I draw a tangent line, notice the tangent line is going to fall below the curve, so it will be an underestimate. So I'm going to put underestimate because the tangent line will lie below curve since the graph is concave up. And you could have something similar to that, just along the same lines. That will be worth 1 more point. All right, and here's our big point getter part C. Find the particular solution to the differential equation dw dt equals 1/25 w minus 300 with an initial condition w of 0 equals 1400. Hopefully, as soon as you solve particular solution, you are thinking in your mind, cross multiply. So I have dw dt equals 1/25 w minus 300, and I'm just going to make that fraction extend all the way underneath. Cross multiplying, I'm going to get 25 dw equals w minus 300 dt. I notice that my variables are not separated, so I'm going to have to divide both sides by w minus 300. Okay, and then I will have 25 dw over w minus 300 equals dt. My variables are separated, so I'm not ready to take the integral. I should officially on this one do a u substitution, so if u is equal to w minus 300, du will just equal 1 dw, which is pretty much there. This 25 we could just bump out front because it's just a constant. So this is going to leave me with 25, the integral of du over u, and I know the integral of du over u is ln, so this is going to be 25 natural log w minus 300, and that will equal the integral of dt will just be t, and don't forget that plus c. All right, from here, if I would like to solve this for for w, I know I need to get rid of the ln, but I can't do that if the 25 is in my way, so I'm going to multiply everything by 1/25, so I'm going to get ln w minus 300 is equal 1/25 t plus c, and now from here I get to do the logarithm loop. So I'm going to get CE to the 1/25 t will equal w minus 300, and then solving for w, I'll just add 300 to both sides. So I'm going to get w equals CE to the 1/25 t plus 300. Okay, so I pretty much have it solved. I would like to now find my C. So they gave me the initial condition w of 0 equals 1400, so I'm going to have 1400 equals CE to the 0 plus 300. That will just be 1, so I'm going to subtract 300. So I'll get C is equal to 1100. So my final equation is going to be y equals 1100 e to the 1/25 t plus 300, and I'm good to go. And one thing that they've shown their answers, I'm not sure how important, what emphasis they put on it, but they did say that this model would work for all values between 0 and 20. All right, and I think, and it said it's the equation for the next 20 years, that's why. Okay, so that is my formula. That was worth 5 points. So if you got the whole thing right, give yourself 5 points. If you need to break it down, here we go. If you separated the variables, give yourself a point. If you found the correct, right at this step right here, if you found the correct antiderivatives or integrals, give yourself a point. If you put plus c, give yourself a point. If you found c, give yourself a point. And then if you came up with the final correct equation, give yourself that 5th point.